Hey, hello everyone. In previous class, we talked about the J.J. Thomson plum pudding model as well as watermelon model. What was that? It is a sphere. The sphere is a positively charged and the electrons are embedded inside it. That we have studied, right? But the one scientist after that, he was not aware about, or we can say is not sure about the things that J.J. Thomson atomic model, which is put forward by the J.J. Thomson, is correct or not. So he conducted the experiment. So what is the scientist name? A Rutherford. Yes, and the model which is given by him is called as a Rutherford atomic model. So you can see a beautiful setup of the Rutherford atomic model. So you can see over there is a compartment or a box-like structure which inside the alpha particle source is there. And then in that box there is a little opening is there, the alpha particle can come out from that. Now here is a question, why only Rutherford chooses the alpha particle? The first point, the alpha particle is heavier and it has a high energy. Now recall the J.J. Thomson model where electrons are embedded inside the positive sphere, so maybe there is a lot of space inside according to the Rutherford. So he was into this assumption, so he choose the or he take over the alpha particle source. Now, when we move to the next part, that is a ring-like structure over there. What is that? A fluorescent screen. And why fluorescent screen? Obviously, alpha particle is going from there. We are not able to see it. Since strike over there, it immediately understood that. What it immediately understood that? It is striking over there. That means what? It passed through it. Now, Rutherford uses the third thing, that is a gold foil. A thin gold foil. Let me clear all that. Again, I'm saying a thin gold foil he chooses. Why? The small number of atom will be there, the accurate observations and the conclusion will be there. So these three things were set up by the Rutherford. Now let's see how the experiment conducted and what is the observation, and at the end we're going to talk about the conclusion of. So now let's talk about how the experiment was conducted by the Rutherford and what was the result, observation, and obviously the conclusion. So here we go. Now you can see a very wonderful overthink 3D interaction over there. So now when you talk about this one, we already talk about this is the alpha particles source. Exactly correct. You can see that radioactive symbol is given. Why? Because it's a radioactive, simple. And what is the reason that alpha particle has been chosen by the Rutherford? The first, they have a high energy and they are heavy in nature. So definitely is going to bombard in a very particular direction. You can see that they are transmitting from here in a straight line. Can you see that? Yes, and you can see that one more thing, the observation, most of the particles are going straight. Most of the particles are going straight as per this thing. And look at this very carefully. We talk about this ZNS, or we easily can say that a fluorescent screen which enables the direction of the alpha particles. And this is a gold foil. Obviously, we know that it is a gold foil. No, it's a thin gold foil. Very good, my dear students, because thin, it represents that a number of atoms will be very less and it will be convenient for the better result. So we talk about this now. What is the first observation? The first observation is that the alpha particle going they directly pass from this gold foil. So we can say a pass through gold foil easily. Exactly correct. Okay. And the second thing we talk about, some of the alpha particles are deflected like this with a small angles, right? Some, we can say some alpha particles deflected. What do you mean by deflected? They wanted to go in a straight line, but they are not going. They are going like this, a small angle they are making, right? So deflected with a small angle. Very good. And the third point, you can see something, a very, very rare point. Out of that, out of this molecule only one atom, alpha particles, not atom, alpha particle is coming back. That means rebound. Rebound of a very few, very few alpha particle is taking place. So what we have just studied, let's recall. Most of the alpha particles are passed through the gold foil. Some are getting deflected with a small angle, and very few are rebound. Okay, so this was the observations. Now moving to the conclusion. See, already we have talked about the setup, then we talk about the observation, exactly what is happening in the case. See, Rutherford carry out this experiment to verify the J.J. Thomson plum pouring model or watermelon model, right? So we have a 3 observations right now. So according on the basis of 3 observation, he concluded something. So let's see what he actually concluded. Okay, now we're going to talk about the conclusions put forward by the Rutherford after that experiment. Now, the first thing he come across is that he put forward the first statement was that the positive charge and the most, what is that? A positive charge and most of the mass of an atom is concentrated in an extremely small volume. He called this region of the atom is nucleus. So, what is exactly it mean that at the center the whole mass of the atom is concentrated. Why so? Because he took a gold foil. Most of the alpha particles are got passed from it. So it means that the atoms are mostly hollow somewhere and the mass is concentrated at the center. The mass is concentrated at the center of the atom. So this is the first statement put forward by the Rutherford. Now let's move to the second point. Now Rutherford talk about the second statement is that the negatively charged electrons surrounded the nucleus of an atom. In the first statement talk about the nucleus, or we can say a center of the mass of the atom is concentrated at the center, that is known as a nucleus, right? And the electron, the negatively charged ones, are revolving around the center. Okay, so he also claimed that the electrons surrounding the nucleus revolve around it with a very high speed in a circular path, and this circular path is called the orbit. So in nutshell we can say that there is a center, mass is concentrated, and the electrons are revolving at very high speed. So this was the second statement put forward by him. And the last but not the least one, that is a very important thing put forward by the Rutherford, is electrons being negatively charged and nucleus being dense concentrated mass of positively charged. So at the center, it is a positive charge. What's that at the center? Nucleus. Very good. And what is revolving around this nucleus in the orbit or circular path? Electron, which is a negatively charged. That's correct. So what is exactly they talk about? They are held together. Now this positively charged electron is not moving here. Electron is not jumping here. Electron is still revolving around that nucleus. And what makes it happen? Obviously the strong electrostatic force of attraction. There is a attraction between positive and negative charge is known as the electrostatic force of attraction. So this electron are held by the nucleus with the help of or with the aid of the electrostatic force of attraction. So this 3 statement has been put forward by the Rutherford. So we have studied the setup, the observation, and here we concluded the result as well. So I hope you understood all the points. We go through all the points and understood in very detail along with that 3D interactive simulations, right? So I hope you understood this topic very well. Thank you so much.